All right, I want to do the boom chain problem. We're going to eventually try to figure out the force in this, the tension in this chain, and we also want to find the force that's working at the end of the boom. And when we can always do that by coming down here and just drawing a force that goes straight into the boom, from the wall straight into the boom, and then another force that's going kind of straight up into the tail of that force. So that those forces can be added together to give us a force like this, and I can figure out an angle below the boom. So I'm always eventually going to try to figure out this force right here. Okay, so one thing, a nice little trick here is to always go to the end of your boom and to draw a perpendicular, like basically the top of a T. So I have a kind of a capital T there. Go to the boom and draw a perpendicular line at the end of that boom, because then that'll help you kind of see how you resolve your forces. So I'm going to take this 4,800 Newton force on the end, the wrecking ball, and I can resolve it into a force that's going like perpendicular to the boom and a force that's going down the boom. I can do another kind of T right here, and so I can go down and then down the boom. And then this chain would be something going up and parallel down the boom. So I have three forces kind of going down parallel to the boom, and then I have this up force right here, which I'll call C1, and then I have these two down forces also. We'll call this force up here C2 also. Okay, so we want to look at a couple of the angles things here. Let's change the color here. And I know that if this is 48, that this angle in here would actually be 42, because this is 90. And if that's 42, then this is 48. And if that's 48, this is also 48. If we also know that this is 48, we know that this angle here, which would be supplementary, should be 132. And if that's 32, then we have two angles, and the third angle should add up to 180. So that would make this 16. And if that's 16, then this is 74. So you can pause the video and see how, if you understand how we get all those angles. Okay, so the first thing we want to do is we want to start here at point P, and we want to find torques around this. So if I come out halfway times this force, plus the full distance times this force, that should equal the full distance times C1. So to do that, first we're going to have to figure out resolve these weights into these forces here on the end. And we can do that pretty easy. This one here would be 3,600 sine of 48. That's 2675. This side here would be 3,600 cosine of 48. That's 2409. You should check these. This side here is 4,800 sine of 48. That's 3567. And this side here would be 4,800 cosine of 48. That's 3212. So if I do my clockwise and my counterclockwise torques, which is how we always start boom chain problems, I'm going to have this force, 2409, and that's going to be clockwise torques. That's going to be 2409 times 0.5. And then I'm going to have 3212 times 1. And that should equal C1 times 1. If I total those all up, then C1 ended up being 4417. Once I have that, I could use this angle here, 74 and 4417, to figure out C2, because tangent of 74 should equal C2 over 4417. And C2 then ended up being 15,404. Now I can use C2, and I can use C1 and use Pythagorean Theorem and figure out the force in the chain, which is half the problem that I need to get done. So that would be 16,025 would be the force in the chain. So that's one of your important ones. Okay, we want to figure out now, what about these forces down here on the end of the boom? So I need to do lefts and rights and ups and downs. So I have lefts and rights, and I have ups and I have downs. And you'll notice I have three lefts. I have this one, I have this one, and I have this one. And if I add all of those up, those three lefts, that would end up giving me, let's see, a total left of 21,646, which is that means that's how much right I need, 21,646. And I know then that goes right here, 21,646. If I look at the ups, I have an up right here, and I have a down here, and I have a down here. So ups is 4417, downs is 3212, and 2409. And if I add those up and then subtract the 4417, I will still have, I need some more up. I will need, let's see, how much up I need. I'd like 1204 up, so that these two add up to the same thing that these two add up to. So that 1204 is going to go down here on this up arrow right there. Okay. Now I can do the Pythagorean Theorem down here, and I get a force here of 21,679 newtons. There's the force on the boom. If I want to find this angle, it would be tangent of the angle would equal 1204 over 21,646, and that angle ended up being like 3.2 degrees. So my final answer down here on the boom is 21,679 newtons at 3.2 degrees below the boom. There would be your force on the boom, and your force on the chain was right here. So that's a lot of yucky stuff there. So hopefully you can play that slower and figure out how we solve that particular problem.